Alright guys, for this video you're just going to learn about reference angles. Probably make the connection tomorrow in class. We're going to connect it to, we're going to get all the ordered pairs in the unit circle, and rather than just memorizing everything, we could apply this concept of reference angles. Okay, first thing you do, just take down the definition right here. Okay, so we have if theta is an angle, to find its reference angle is the acute angle formed by the terminal side of theta and the x-axis. So let me underline that too, x-axis. Okay, the acute angle. So when you find a reference angle, the reference angle is in between 0 and 90 degrees. If it's in radians, then it's in between 0 and pi over 2. Okay, I could take any ordered pair in the unit circle, whether it's in quadrants 2, 3, or 4, and I can refer it back to the first quadrant, which is in between 0 and 90. Alright, 4 cases. We're going to look at if the angle's in the first, second, third, or fourth quadrant. Okay, and I'm just going to draw this right here. If you have an angle in the first quadrant, I'm going to draw this out. I'm going to say this is theta. Now, if you have an angle that's in the first quadrant, its reference angle is itself, because it's already between 0 and 90. It's already an acute angle. And if I measured this, it's saying its reference angle is from, here's the terminal side, to the x-axis. Okay? And it wouldn't be terminal side to this x-axis because here, that's obtuse, it's not acute. So its reference angle really is just itself. So I'm just going to put here, I'm going to say theta prime. I'm going to say that's the reference angle, and that's just equal to the angle itself. So there's really no thinking. If you had 50 degrees, its reference angle would be 50 degrees. If you had pi over 4, its reference angle would be pi over 4. Okay, let's move to the second quadrant. Okay, if I draw an angle in the second quadrant right there, there's my terminal side, right here's my initial side. So if I measure it, I say this is theta, that rotation. Now when I look at it, it's saying it's the acute angle formed by the terminal side. Well, this is the terminal side and the x-axis, so I want to find, this is its reference angle, this little sliver right there. Okay, that's acute. So to find this angle, I know if I go from here all the way to here, it's 180. So I'm just going to do 180 minus this angle, theta. So its reference angle is just 180 minus whatever theta is. If you have it in radians, then it's pi over 2 minus theta. Okay, let's move to the third quadrant. Okay, so if I draw this, the third quadrant, let's put this right here. There's the third quadrant. This is the initial side. So if I measure this, that's theta. And its reference angle, it's always just a little piece. It's the terminal side to the x-axis, and it's going to be here. Right? It's not this measure because that's not acute. It's just that little piece right there. So for this one, to find its reference angle, we say theta prime, this is just going to be, let's see here, theta prime is, theta prime is just the original angle because you're past 180 minus 180. And if you had this in radians, it's just theta minus pi. Okay, so now you're just kind of setting up the definition. Now if I draw an angle in the fourth quadrant, okay, here's the terminal side in the fourth quadrant. Here's the initial side. So if I measure it, I go all the way around to here. This whole angle is theta. Now its reference angle, right? Here's the terminal side, just this little piece, right? Here's an acute angle from the terminal side to the x-axis. So to find that, really if I go one revolution, it's 360, and it's going to be minus whatever this theta is. That'll give us that little sliver. So its reference angle, theta prime, is 360 minus whatever the angle is that's given. If you have it in radians, then it's 2 pi minus the angle that's given. Okay? So these are just the definitions. Just make sure you take that down, and we'll probably go over these examples on the bottom tomorrow in class.